we know that A, B, and C are all positive. Everything's bigger than 0. And we know that A is the littlest, and C is the greatest, and B is somewhere in the middle. And we're trying to determine which of these Roman numerals must be true always. And let's take a look. Roman numeral 1. Based on this information, must it be true that 2a is greater than b plus c? Well, if we're using algebra, I don't know, nothing jumps out at me as a very obvious way to simplify this. But I think we could do something to make it a little bit easier to think about. Let's see. Right now, this side is a sum of two quantities, and this side is just 2 times something. But it might be easier to compare the two sides if they were more similar. So let's make this side a sum. 2a could be rewritten just as a plus a. And then this side is still b plus c. So let's see, what does this do? Well, I don't know. For me, it makes it a little bit easier to think about. Now I'm saying, okay, I take the little guy and I add another little guy, and then I get something bigger than the medium guy plus the biggest guy, which actually sounds a little bit weird to take 2 little guys and get something bigger than 2 things that are each bigger than that little guy. And so that's maybe enough right there to get rid of Roman numeral 1 and say, actually, this is not true. But I don't know, maybe there's another way to organize that reasoning, which, of course, it varies from person to person what the best way to think about a statement or a Roman numeral is. Here, rather than that sort of, 2 little guys way of thinking, we can compare the two sides of this inequality piece by piece. We can say, well, this a here is definitely smaller than this b over here, right? A is smaller than b, so this part is smaller than this part, and this part, this a, is smaller than this c, right? And that's something else we know, is that a is smaller than c. So that means that on both counts, this side of the inequality is smaller than this side. Well, I guess that means that this whole side must be smaller than this whole side. In other words, it's just not true that a plus a is bigger than b plus c, and so we can just get rid of Roman numeral 1, and we can get rid of all the answer choices that include Roman numeral 1. A is gone, and D is gone. All right, Roman numeral 2. Given this information, must it be true that c minus a is greater than b minus a? Well, if we're doing algebra, I guess the first thing we might notice is both sides have a minus a. Both sides are just something minus a, so what we could do is just add a to both sides to get rid of that. We could just rewrite this as c greater than b. And I'm allowed to do that, right? Like for plus and minus, for addition subtraction, inequalities are exactly the same as equations. I can add the same thing to both sides. I can subtract the same thing from both sides. So if I have a minus a on both sides, I can just get rid of it by adding a to both sides. So Roman numeral 2 can be rewritten as c greater than b. So does this have to be true based on this information? And yeah, it does. We're told that c is greater than b in the stem. So yeah, it must be true that c is greater than b. So we've got to keep Roman numeral 2, and we've got to keep all the answer choices with a Roman numeral 2, which means c is not our answer. What about Roman numeral 3? Must it be true, based on this information, that c over a is less than b over a? Well, again, if we're using algebra, I want to make this look a little bit better. And, well, I'll tell you what I want to do. I want to get rid of those a's in the denominator. I want to just multiply both sides by a so that the denominators cancel and just life gets a lot easier. So am I allowed to do that? Am I allowed, in other words, to multiply both sides of an inequality by a variable? And the answer is that, well, it's a little bit of a complicated answer, but it's an important answer. The answer is yes. In this scenario, for this question, I can. But the only reason I'm allowed to do that is because I'm told that a is greater than 0. I already know that a is positive, and therefore I am allowed to multiply both sides of this inequality by a. We'll make some other videos about why it's so important to know that a is positive. But in brief, for inequalities, recall that if you multiply both sides of an inequality by some negative number, you flip the direction of the inequality sign. And if you multiply both sides of an inequality by a positive, you don't. So if you multiply both sides by an unknown, by a variable, you have to be really careful. Because if that variable could be a positive and could be a negative, well, then you don't know if you're supposed to be flipping the direction of the sign or not. You don't know if that variable is filling in for a negative, in which case we would have to flip the direction of the inequality, or a positive, in which case we wouldn't. Here, thankfully, we're lucky. We're told that a is positive, so we can just multiply both sides by a and get rid of those denominators. And I know that this is kind of sort of involved thinking now, but by test day that's quick. Although I want you to pause when you have an inequality and you want to divide or multiply both sides by a variable. Just think very carefully about whether you know the sign of the quantity that variable is filling in for. But here we've got rid of our a's. We're left with c less than b. We've got c less than b. So based on this, must it be true that c is less than b? Well, no. We're told that actually that c is greater than b. So this in fact must be false. This is not something that must be true. So Roman numeral 3 is gone, and therefore answer choice E is gone, and therefore we click B and get our points.